yung first yung introduction to feedback control systems natin. We will discuss them paunti-unti, okay? And then let's see what we will be able to finish today or tonight. Okay? So, pero basically what would happen is that I would be finishing up kung ano man yung matapos ko dito. Pero itutuloy niyo ito, okay, by watching recorded discussions, okay? That discusses these topics, itong mga topics na to. Okay. So, we'll introduce ourselves first, or we will orient ourselves first with what control systems engineering is all about. Okay? And in that case, you would be oriented on the terms and the definitions that is used when control systems engineering is being discussed. Okay, so let's start. So basically, control systems are integral part of modern society. Okay, so there are numerous applications of control systems around us. Okay, some of the given here, like the rocket's fire and the space shuttle lifts off the Earth's orbit. In splashing cooling water, a metallic part is automatically machined. A self-guided vehicle delivering material to workstations in an aerospace assembly plant glides along the floor seeking its destination. These are the things that you really don't see in everyday sense. Kasi mga advanced applications yan ng control systems engineering. Okay, you don't see every day that rockets are being fired. Okay? And if you see rockets being fired, it's likely na hindi yan sa Pilipinas kasi hindi pa naman wala tayong capability to launch rockets. Okay? And space shuttle is actually a defunct American space mission. Okay? Ngayon wala nang space shuttle, pero pinalitan nila yung panibagong commercial program. Okay? We don't see every day that a metallic part is being machined or is being constructed or made. Okay, such as for example yung mga bolts and nuts na ginagamit natin to fasten things. So nakikita lang natin na meron tayong mga bolts, meron tayong mga nuts, pero we don't really see how they are actually made or how they are actually constructed and paanong napagkakasya natin yung isang certain size ng bolt napagkakasya natin sa isang certain size ng nut. Okay, paanong saktong-sakto silang pipin. Okay. Self-guided vehicle or what we call autonomous vehicle is something also na hindi pa natin masyadong nawi-witness dito sa Pilipinas. Okay. Pero in that case, marami pa namang examples ng control systems na everyday na halos nakikita natin, or at least noong nakakalabas pa tayo, everyday nakikita natin siya. Okay. Now, we are not only creators of automatically controlled systems. Okay. These systems also exist in nature. So there are natural control systems that we can see all around us. Okay. For one thing, ang katawan natin is within our bodies are numerous control systems. Okay. For example, yung immune system natin, yung ating brain, okay? Yung ating nervous system, yung ating muscular system. These are control systems basically. Okay? So one thing would lead to another once na merong trigger or merong input na natatanggap yung ating katawan from the outside world papunta sa and our body would interpret those inputs in terms of what we have learned on how these inputs have been. Okay, for example, kung nararamdaman nating mainit, okay, our skin actually senses that mainit siya. Okay, so therefore our brain would try to adjust on that level of hotness, okay, or of that temperature. Okay, so hindi lang man-made ang mga control systems. They actually exist in nature. Pero here's the thing, ang isa sa mga current direction, okay, one current direction that your control systems engineering is going into is actually adapting these natural control systems into machine control systems. Okay, for example, you might have heard of artificial neural networks. You might have heard of that, okay, or ANN. Narinig nyo na nga ba to? Were you able to have at least read about neural networks? Okay, so a neural network, okay, basically is ang artificial neural network or ANN is basically a computational algorithm. Okay, this is an algorithm basically. Okay, that mimics how the brain learns through firing of signals through neurons. Okay. It is said na yung brain kasi natin actually learn things, okay, by having this synapses, okay, travel or fire off and travel across a network of neurons inside our brain. So mas as we learn, these neurons becomes numerous, dumadami siya. Okay, they increase in number. Okay, and therefore that is the sign that we are actually learning. Okay, so in the case of artificial neural networks, they actually start off as parang mga nodes of mga computational nodes siya. Okay, mga computational nodes siya in which the weights of these nodes are being adjusted. Okay, so may mga formula at may mga algorithm na sinusunod siya in order for the artificial neural network to learn how to do things, so that meron ka na lang, para ang mangyayari na lang doon is that you would have a certain input na ipapasok mo sa artificial neural network mo, tapos magpo-produce siya ng output. Okay, pero before you actually do that, you have to actually train. Okay, you have to actually train which means bibigyan mo si artificial neural network mo ng ito yung input, ito yung output, ito yung input, ito yung output, ito yung input, ito yung output. Ibibigay mo yung signal na yon dun sa artificial neural networks mo. And then you would have to let the neural network to learn, okay, through the process called training. Okay, and then later on, kapag katapos na siya sa training, the neural network can actually now produce a certain output for a given input. Okay, can now predict kung ito yung input mo, mape-predict niya na kung ano yung pwedeng output mo. Okay? So, and that is one example of we engineers adapting natural control systems into our other control systems that uses another application. Okay? So, yun. So yun yung efforts that we are ushering our control systems engineering into. Okay. Although what we will cover here in our course is what we call yung classical control theory. Okay, the classical control theory in which we would cover topics, okay, that are discussed, okay, nung medyo bago-bago pa yung field nung control systems. Okay, that's why it's called the classical control theory. Okay. Pero it wouldn't prevent us from also talking about some of the technological advancements, kasi yung pag-advance ng control systems engineering, from way before up to now, okay, is sumasabay din sa availability ng technology, nung mga systems, ng mga components, okay, ng mga materials, sumasabay kasi siya doon. Okay, so therefore, since ngayon yung technology natin is really advanced, okay, most of which actually is ushered by advances also in control systems engineering. Okay. So, ayun. So, before we embark on the main topics, okay. We first define what a control system is. Okay. So here, your control system is defined as something that consists of subsystems and processes or plants assembled for the purpose of obtaining a desired output with desired performance given a specified input. Okay? So, isa-isahin natin. Okay. Number one, your control system consists of subsystems and processes or plants. Okay? So which means your control system is not really just a single component system. It actually consists of many components and systems that are interconnected. Okay? They are interconnected in order for you to come up with a certain function. Okay? So, pwedeng ganyan yung connection natin. Mali yung ano ko. Hindi siya consistent dun sa ano. Yan. So, maaaring ganyan yung loob ng control system nyo. But basically, we can actually reduce this. Okay, later on we will have a lesson in which this complex system consisting of many subsystems. In this case, there are 3 subsystems here. Okay, consists of many subsystems to be simplified into a single block system. Okay, kasi madalas we will be talking about we will be talking about systems having a single block. Or we will be talking about systems that can be reduced into a single block. Okay, pero tatandaan natin that our control system is much more complicated than that. Okay, that is, it will contain different, a certain number of subsystems that are interconnected in a manner so that we can generate an output given a certain input. Okay, is that clear? Okay. Now, sige, pababa na. Now, what is the purpose of your control system? Okay. The purpose is to obtain a desired output. Okay. With a desired performance. Okay. So, what is desired output? Okay. The desired output actually pertains to your expectations of the system. Okay? What happens is that kapag meron tayong control system, normally, meron tayong gustong ipagawa dun sa system natin. Okay? One example that I always give, or the book gives to the students, yung reference book natin is yung elevator. Okay? So, yung elevator natin, alam natin na ang, sorry. Ayun. Okay. We know for a fact na yung elevator natin needs to be commanded. Kailangan nating i-command yung elevator natin in order for it to go to a certain floor. Okay? So, ayun. We need our elevator to be commanded in order for it to go to a certain floor. Say for example, nasa first floor yung ating elevator. So, halimbawa ito yung first floor. Okay, this is the first floor. Andito yung elevator natin. Okay, we need our elevator to go, so ito yung first, to go to the 4th floor. So, kailangan nating pindutin yung button dito sa elevator para pumunta siya sa 4th floor. Okay, tama ba yun? Ganun yung proseso ng elevator. Tama? Kailangan may pindutin kayo. Okay? So, in that case, pagka napindutan natin yung 4th floor nito, what would happen is that the elevator would then ascend. Okay, would then start to ascend papunta sa 4th floor. So, ito, the manner by which we actually command. Okay? The manner by which we command or we send commands to your system, okay, is what we call the desired output. We desire that the elevator would go to the 4th floor. Okay, that is our desire. Okay? So, saglit lang ah. Sandali lang ah, meron lang akong ginagawang adjustment ah. Medyo napaglaruan ko bigla yung camera. Wait lang. Ayan. Sorry. Parang naliliwanagan kasi ako sa camera ko eh. Ayan siguro. Ayan, okay na siguro yan. Okay, anyway. So, as I was saying, itong command natin, okay, itong command natin that we use, okay, for the elevator to ascend to fourth floor is something that we call as your desired output. Okay? So basically, your desired output pertains to the expectation. Okay, we expect that our system to go to the fourth floor. Okay, or basically another term na pwede natin gamitin dito is we want. Okay, we want our elevator to go to the fourth floor. That is why ginagamit natin yung term na desired kasi we want. Okay? And if you want something also, you also use the word command. Okay? In that context. Okay. So these things, okay, itong command, itong want, itong desired output. Okay? Or basically itong command. Okay, it's basically something that we would like our system to achieve. Okay? And so, that is why we consider this desired output, okay? Itong desired output itself as an input to your system. Kung meron kang system, if this is your system, okay, ang i-input mo dyan is your desire. Okay? Or your desired output. What do you want your system to achieve? Okay, so this is your system. Ano yung gusto mong ma-achieve ng system mo? That is your input to your system. Although, take note na although the phrase includes the term output, pero bakit ko siya ginagamit sa input? Again, your desired output is basically a command to a system. And command is an input. Okay? So therefore, i-consider natin yung desired output as an input to your system. Now, what would happen is that your system would produce a certain actual output. Magpo-produce siya ng certain output niya. Okay? Based dun sa in-input mong desired input or desired output. Okay? So, ang kinaiba ng system, okay, kinaiba ng system sa ibang, say for example, signal processing system is that yung signal processing system nyo kasi does not really take in desired output as an input. Okay? Ang ginagawa natin sa signal processing system is that we place an input signal, okay, into your system. And then that input signal is processed by your system to produce an output. Okay? In the case of control systems, our output or our input is basically a command, not just any other signal or any signal for that matter. Okay? Parang puti nung kamay ko sa ano. Nag-glow siya. Weird. Teka lang ha. Ganun pa rin. Okay. So, okay. So, sorry, medyo napaglalaro ko yung camera. Okay. So, yung control system natin, okay, our control system is basically takes in a command as an input. Not merely just a simple signal that it needs to process. Okay? Ang objective ng system ninyo, okay, the objective of your system is to actually follow that command. Okay, if I order or if I command my system to go from one point to another, the response of the system was to actually go from this point to this point. Okay? Whether or not it actually reaches the point that I would like your system to be. For example, Katulad nga ng elevator, pwedeng ano yan, sasakyan yan, autonomous vehicle. So if your vehicle is at this point and I would command it to go to this point, okay, it would try to move towards this. Pero it might not reach exactly, okay, that particular point that I would like your vehicle to be placed or to be located into. Okay? So, yung ganong usapan is another matter. Kung gaano ka iba siya, this difference, okay? This difference between the desired, this is your desired, okay, and this is your actual, okay, or this is your command input, and this is your actual output, okay? The difference is another matter of topic that we need to talk about. Okay? So, naintindihan yung context ng desired output in terms of the definition of the control system. Okay. So, ayun. Now, so that is for the purpose of obtaining desired output with desired performance. Okay. So let's talk about the desired performance. Okay. In what way we look at the performance of your system? Okay. In what way do we look at the performance of your system? Okay. First thing is that the response of the system, or when you say response, tandaan nyo, when you say response, it means output. Okay. Now, when you say time response, okay, when you say time response, it means the output or how the output changes. Okay, how the output changes over time. Kasi may time element na siya. Now, this output, okay, this output can be of any quantity. Okay? Pag sinabi niyong output, ano yan? Depende pa sa kung anong quantity ang pinag-uusapan natin. That output may be in terms of position, okay, or displacement. And your displacement can either be linear displacement. Okay, kagaya nito. Linear displacement yan. Okay. It can be angular displacement. When you say angular displacement, it means you measure the difference between the position in terms of angle. As in, nakita na ba yung thermostat? Yung pinipihit niya sa aircon. Okay? So yung difference between yung differences between the initial position of the thermostat at saka kung saan niyo siya i-set. Okay? Itong difference na to is measured in terms of angular displacement. Kasi pabilog yan umiikot siya. So therefore, we measure that angular position in terms of angular displacement. Okay? So ayun. Or your output can be in terms of rate. Okay, pwedeng speed, pwedeng flow rate, basta rate. Okay, pwede ring rate of change of speed, in which we define this as acceleration. Okay, and so on. So therefore, these are the ways we actually specify output. We use the term output in general. Pero basically, in a particular system, we refer to the output as any of this. Depende kung ano yung variable that we control. Okay? Or that we are considering. And in the case of tatandaan din natin that in the case of control system, the output is also what we call a controlled variable. Okay? So, yung output natin can also be considered as a controlled variable. Basically, because this is a control system, so yung output ng system niyo or yung output ng control system niyo is basically what is being controlled. That is why we design the system, okay, to control, say for example, position. Okay? So, when we say that a system is called a position control system, okay, kagaya nito, this is actually, an elevator is actually an example of a position control system. It means that the output of the system is position. And it means that position is a controlled variable. Okay? So those are the things that we have to remember about this, about these things. Okay? Maliwanag ba to? Okay, so sige. Now, balikan natin yung performance kasi nandun ako, I was talking about performance eh. Okay. So yung performance natin is actually based on the time response. Okay? Your performance is based on the time what we term or what we consider as the performance indicator of your system is actually based on the time response. And the time response of your system can actually be summarized using this graph below or this graph here. Okay? So paano ba natin i-interpret tong Paano ba natin i-interpret tong graph na to? Okay. Basically, this is how your elevator would respond. Okay? The output variable here, okay, yung variable dito sa y-axis is the position of your elevator in with respect to the first floor. So kung gaano kalayo na siya sa first floor, that is what we that is what we represent with the y-axis. Okay. Sa x-axis naman is yung time. So which means we are taking or we are interpreting this curve as to how your elevator, okay, changes its position over time. Okay, so at the start, for example, nasa first floor siya. So at time 0, nasa first floor siya. Okay, now once na pumindot kayo ng fourth floor, okay, now your fourth floor or yung button 4 pag pinindot niyo sa elevator, you would now have set your elevator to go to the fourth floor. So we are expecting now that your system or your elevator would go here. Okay? Kailangan mapunta siya dyan. Okay? So that is your input command or that is your command. Okay? Or that is your reference. Okay? Yun yung mga tawag natin dito sa fourth na to. Okay? Or doon sa fourth floor. It can be your reference. Okay? Reference. It can be your command, okay, and so on. Okay, now what would happen? At the instant that your elevator moves, so it actually would move away. Okay, it would move away from the first floor, paakyat, papuntang fourth floor. Okay, but take note that it would actually take some time for it to reach the fourth floor. Hindi naman yan agad-agad na bigla na lang magiging fourth floor. It would actually take some time. Okay, for it to go to the fourth floor. And when it is near the fourth floor, it would actually stay in place. Okay, it would actually stay in place now. Okay. So in this case, we would be able to see two parts. We call this now itong curve na to that I traced using dots, green dots. Okay, yung tinrace ko na curve na yan is actually what we call the time response or the elevator response. Okay, or specifically, the position of your elevator with respect to time, being the position your output variable. Okay, so pero basically ito yung time response natin, or we will represent your time response in this way. And your time response in any cases or in all cases, okay, that we will have to consider. Your time response would always consist of two components or two parts. Okay, it would always consist of two parts. The first part is the transient response. The first part is the transient response. Okay. So the transient response is basically when we define transient response, nang hindi pa mathematical kasi we will define transient response later on, pero in mathematical terms. Pero in this case, let us define transient response in ano muna, in layman's terms muna. Okay, so when you say transient response, it means the immediate reaction of a system to a command. Yan. What happens is that when you have a system, or when you have a system in equilibrium or in a certain state, okay, at siya ay nakasettle dun sa particular state na yun, what happens is that if you actually command that system to say respond, okay, to a command, okay, the system would actually be parang magugulat siya ng konti or parang magkakaroon siya ng konting reaction. Okay. And that immediate reaction that we can measure, okay, is what we call the transient response. Okay. Now, the transient response would actually lead into something that it would lead the system to settle on or very near the command. Okay. So, makikita nyo ngayon dito na yung part kung saan from the first floor, which is nakasettle siya sa first floor, okay, until the time na ito, okay, is what is being covered by your transient response. Yan yung reaction niya. Okay. Now, what would happen kasi is that the system would actually try to achieve a certain settling value. Magsisettle siya sa isang value. Okay. That is on or near the input command. Okay. It would settle at a value that is on or near a certain, on or near its input command. Okay, so ito yung part na yun, na kung saan nagsettle siya. Okay, nagsettle siya dun sa value that is on or near your input command. Ayan. Okay, and this part of the response, okay, this part of the response wherein your system now is settled, okay, is settled into a value that is on or near the command, is what we call the steady state response. Okay? So the steady state response is that part of the response that part of the response when the output, okay, settles on or near the input command or reference value. Yan. So that is your steady state response. Okay? Take note lang ha, ginamit natin yung when. Okay, when which means it actually pertains to time. Okay? So dahil nga yung ating x-axis dito is basically it basically covers time. The question is when, okay, will this happen? When will the system or when will the output, okay, will settle, okay, to a value that is on or near the reference. Okay? So, ayun, that is why we use the word when. Okay? And I would like to emphasize the use of the word settle. Okay? Kasi when students define steady state response, instead of the word settle, they actually use the word stabilize. Okay? They actually use the word stabilize. Okay? Which I won't say na mali. Pero in this context kasi, hindi siya proper term. Okay? Dahil ganito. Yung word kasi na stable or word na stability or word na stabilize, gagamitin natin to describe a system. Okay? kumbaga may iba tayong usage ng ng stabilize or ng stability or ng stable, okay? In which it should not apply to signals. Okay? Yun yung tatandaan yung keyword doon. Stability, stabilize, stable should not apply to signals. Okay? Tandaan nyo na yung response is a signal. So therefore, it should not apply or it should not be used to substitute the word stabilize should not be used to substitute for settle. That is why ginagamit ko yung word na settle instead of the word stabilize. Okay? Gagamitin natin yung stabilize to describe a system, not a signal. Okay? Is that clear? Okay. One thing that I would like you to really learn is to when to use correct words. Okay. Kapag meron tayong ganitong technical na pinag-uusapan, I would like you to really learn how to use these words correctly. Okay, because iba kasi yung alam natin or iba kasi yung alam talaga natin yung tamang gamit ng mga words na meron tayo, especially when we're talking about technical matter. Okay? So that is why ini-emphasize ko to, that we don't use the term stabilize or stable or stability to describe a signal. Okay? Tandaan nyo, response is an output. Okay? Response is output. Output what? Output signal. Okay? Response nga siya. Ibig sabihin, ano yung response or ano yung reply ng system, ano yung sagot ng system dun sa binigay na input sa kanya. So therefore, that is a form of a signal. Okay? That is a form of the signal given off by the system. Okay? And in that case, sa atin, although sabi ko nga sa inyo, hindi naman talaga exactly mali. Pero sa atin lang, we don't really use the word stabilize to describe a signal. Okay? We use the word stabilize to describe a system. The system stabilizes. Okay? Or the system is stable. Okay? But we don't say that the response is stable. Or we don't say that the system or the output signal stabilizes. No, we don't say that. We don't say that. Mali yun. Okay? That is wrong. Okay? What is correct is we use the word settle na lang instead of the word signal. Instead of the word stabilize. Okay? So these are the two parts of your time response. You have transient response and then steady state response. And then from there, we will now be able to define ano yung major measures or ano yung performance, what performance indicator or what performance characteristics do we look into when we have a control system. Okay. The number one is the transient response itself. Basically, what we answer here is how fast. Okay? How fast does your system produce the response, or how fast is your system settles to. Okay? Settles to a value that is near or on the reference. Gaano kabilis niyang ma-achieve ito papunta sa point na to? Gaano kabilis ito? That is what we answer in the first question or in the first performance indicator. That is what we characterize, okay, in the first bullet in terms of the transient response. Okay, how fast is your system responding to an input so that it reaches the settling value or the value by which it is on or near the input command. Okay, so that's one. Number two, the second performance characteristic that we look into, is the steady state error. Okay, so since this is a steady state error, it means that we have to measure the steady state error from the steady state response. Okay, so we need first your system to be at settling value. we need our system to be settled at the we need our response to be settled at at a settling value. Okay. Now, the difference then in between your reference or your input command and your actual actual settling value, is what we call the steady state error. Okay, katulad nung binanggit ko dito kanina. Sinabi ko naman sa inyo that it doesn't necessarily mean that the command is actually the same as what the system has actually achieved. Okay, or actually obtained. Okay, meron pwedeng difference yan. And this difference is what we will consider as your steady state error. Okay? Is that clear? Yung dalawang yan? Okay. So, all throughout the course, we will devise methods on how to measure this, how to measure these two. Okay, and at the same time, at the later part of the course, we will learn how to actually control them. Paano natin makokontrol yung yung dalawang yan or yung characteristics. Okay, how do we can actually make this performance characteristics desirable. Okay, again ang definition natin dito is that we have a desired performance. Okay, now your system may be characterized by these two, the transient response and the steady state error, pero baka hindi naman siya desirable. Okay, baka yung characteristics, yung transient response characteristics and yung steady state error characteristics of your system is not really something to be desired of. Okay? And therefore, what we can do is we actually design your system or redesign your system in order for these things or these parameters or these characteristics to become desirable. Okay? That is one objective of your system. Later on, magbabanggit tayo ng objectives of control systems engineering. Okay, we will state what are the objectives of the control systems engineering. Okay, and that's for later topic. Okay, now with control systems, we can move large equipment with precision, point huge antennas towards the farther reaches of the universe to pick up faint radio signals. Elevators carry us quickly to our destination, automatically stopping at the right floor. Okay, now we build control systems for these 4 reasons. Okay, these are the primary reasons why we build control system. So number 1, power amplification. It allows us to actually amplify the power or multiply the power that we exert. Okay, especially halimbawa, may gusto tayong buhatin. We want to lift heavy objects and we really don't and as humans, our strength is being limited we will use now machines in order for us to carry this heavy load. Okay, so systems such as crane, yung nakikita nyo sa mga construction, di ba? Merong makikita kayong matataas na cranes, okay, in which that crane carries heavy load. So ito yung load niya. Okay, from this point papunta doon sa kabilang point. Okay, that is an example of a control system used for power amplification. So a crane used for lifting heavy, not just lifting, also moving. Okay, heavy load. Okay, that's an example of a system that is used for power amplification. Okay, remote control, number 2. We also use control systems in order for us to remotely control systems, such as in the case of, say, satellites. Okay, so meron tayong, for example, satellite. Okay, now these satellites, most of the satellites that we use, okay, has a certain distance, okay, to the ground. Okay, or from the ground. Meron siyang certain distance of the ground that needs to be maintained. Okay, dahil meron niyang certain footprint especially if this is a communication satellite, no? Okay? Meron siyang certain footprint para yung coverage niya naka-fix dun sa Earth. So, meron tayong tinatawag na satellite footprint. Okay? And for your satellite to maintain such footprint, okay, it should maintain its position in space. Okay? But what if something happened to your satellite? Say for example, there is an asteroid. Okay? O kaya space debris. Okay, space debris are those garbage that are left floating around the space outside the Earth's atmosphere. Okay, may imagine niyo yan na makalat na rin kung makalat ang Earth mismo. Okay, mas makalat yung nandun sa taas ng atmosphere natin dahil ang dami ng bakal, ang dami ng satellite, mga patay ng satellite, and so on. Nandun na. Okay, so what if one of those actually strike your satellite? So it may be off position. It may be put off out of position. Okay? So what we can do is that we have here an Earth station. Okay, kung wari nandito yung Earth station. Okay, that can actually send signal dun sa inyong satellite in order for it to blow off some of its thrusters. Kasi may mga thrusters yan may mga parang rocket pa siya. May mga parang rocket mechanism pa siya so that it can move around when needed. So you can actually send signals towards the satellite so that the thrusters fire off and then it would put itself again into position manually. Okay? So you can manually put a satellite back into position using remote control. Okay? But you can also do that automatically. That is, kapag na-detect ng satellite, that it was knocked off, that it was knocked off its position, if the satellite itself detects that it has been knocked off out of its position, it is possible na that the satellite can actually can by itself automatically correct its position into space. Okay, pagka ganoon naman, pag automatic naman yung kanyang mechanism in order for it to be put back into its position, it is considered a mechanism for compensating for disturbance. Being this, yung space debris or yung asteroid na to, striking your satellite, a disturbance. So if the satellite can actually correct itself, correct its position itself by itself, then it is compensating for the disturbances around it. Okay. Pero pag manual yung control, then we can consider it under the remote control. Okay? So, two situations, different scenarios, two different purposes. Okay? Pero basically, sa isang satellite system, both can actually be done. Okay? Pwedeng may manual control, pwedeng may automatic control. Okay? Now, are these understood? Yung tatlo na yan? Tatlong reasons na yan? Naintindihan ba yan? Okay. So, last reason here is yung convenience of input form. Okay. When you say input form, it pertains to the quantity, representing the input. Okay? The input form itself, okay, means the quantity representing the input. Okay. Here's the thing. Halimbawa, may control system kayo. Okay. That controls, say for example, yung control variable ninyo is temperature. Okay. Now, temperature is something is something that is something that cannot be controlled or is something that is controlled via activating other things. Okay? Like for example, in the case ng aircon, sa case ng air conditioning system, okay, by blowing cold air into the room, it actually lowers the temperature. Okay? Or by blowing hot air into the room, it actually raises the temperature. Okay, pero sa case natin in the Philippines, we actually ang objective ng natin ng air conditioning systems natin is to actually lower the temperature. You rarely hear people here in the Philippines use aircon to actually warm up a certain room. Baka meron sa mga malalamig talagang lugar, pero here madalas sa atin, we actually use aircons to lower the temperature. Okay? But how do we control this temperature using your aircon is not really related to the temperature itself. Paano ba natin kinokontrol ang aircon? How do we control aircon? The air conditioning, yung air conditioning niyo, paano niyo sineset yung temperature niya? Anyone? Pwede kayong sumagot sa audio, pwede kayong sumagot din sa chat. Paano nyo kinokontrol ang aircon? Paano nyo siniset pala yung temperature ng aircon? Actually, dalawa yun. Depende sa aircon niya. So, magbigay tayo ng methods kung paano siya gawin. Anyone? Magbibigay ako ng isa. Kung yung aircon nyo is the remote, yung remote control, okay, you use push buttons. Okay. O yun, sakto kami ni Miss Marohom. Ang binigay ko yung merong remote. So, sa kanya yung walang remote. So, sakto. So, kapag ka may remote, i-discuss ko muna yung may remote. Meron kayong push buttons. Okay, in order to set the temperature. Okay. That's one. Ngayon, yung sinasabi ni Miss Marohom is pag wala kayong remote, may low, medium, high, cool kayo. Pero paano niyo siya sineset? Yung low, medium, high. Ano yung ginagalaw niyo? Kasi ito kasi yung pino-point ko sa convenience of input form. Yung kung ano yung ginagalaw ninyo in order for you to set the temperature. Di ba doon sa scenario na dinidescribe ni Miss Marohom, meron kayong parang iniikot? Di ba? Anong tawag niyo doon? Meron kayong parang iniikot na ganun para ma-set nyo sa low, medium, high, cool. Okay. Anong tawag nyo doon sa iniikot nyo na yun? Anyone na nakakalam nun? Sa tawag na yun? Ayan, alamin natin yung susunod na. Pero ang tawag natin doon, thermostat. Okay. Ayun, thermostat. Tawag natin doon, thermostat. Okay. We call that that knob, okay, thermostat. Pero basically, that thermostat is a potentiometer. Okay? Is a potentiometer. Ano yan? That's a form of a potentiometer. Okay? So basically, ang sinasabi natin convenience of input form is this. By using a push button, by the use of push button or a potentiometer, we can actually set your temperature. Okay? So, control systems can actually make can make us conveniently set, okay, the control variable by using different methods of input mechanisms. Okay? And this provide convenience, okay, in terms of setting your output or your control variable. Okay, so this is an example of how we can use your control system to provide convenience in setting your input. Okay, is that clear? Okay, so sige. Pababa na. So that those are those are the ways, or those are the reasons why we build control systems. We use it to amplify power, to control systems remotely, to set inputs conveniently, and to compensate for disturbances. Okay? So now moving on from this one, okay? We now discuss the different configurations, or basically in this case we will discuss only two. Okay? But just remember that as the study of control systems engineering develops, okay, as the field of control systems engineering develops all throughout the time na sumasabay siya sa technology, this configuration also becomes complicated and complicated. Okay? So yung pag-uusapan natin dito are the configurations that relate to the classical control theory. Okay? Pero basically, every system can be boiled down or can be reduced down into any of these two forms. Okay? Although ang ang concentration ng ang concentration ng ating course is the second configuration. Okay? So, we have here the open loop system, okay, and the closed loop or the feedback control system. Now, at a first glance, tingnan natin tong diagram na to, tsaka tong diagram na to. Okay. Malaki na yung, obviously, kitang-kita na kagad natin yung difference ng dalawa. Okay, tama ba? Kitang-kita natin yung difference. Okay. And that difference, okay, good. And that difference is this one, yung presence nito, which we call the feedback loop. Okay, the presence of the feedback loop settles the difference between a closed loop system and an open loop system. Okay? So, pero basically, the components between, pwede ko pala yung ganito, no? Ngayon ko lang siya naisip. Ayan. So, the components between an open loop system and a closed loop system are basically the same, except for the presence of this feedback loop and this thing called the output transducer or sensor into the closed loop system. Okay? So basically, pag-usapan muna natin yung components na common sa kanila. Okay? So ito. Okay, so the input or reference signal is taken in by the input transducer. Okay? So this is your input or reference signal. This is your command. Okay? And is taken in by the input transducer. Now, what does the input transducer do? The input transducer converts the form of the input signal to the form used by the controller. So whatever form of the signal that is being used by the controller, okay, the input transducer would convert the input signal papunta dun sa anything that is being used by the controller. But here's the thing. Since we're talking about electronic control systems or control systems or automatic control systems in the case of a closed loop system. Okay? Itong controller na to is usually an electronic circuit. Okay? Usually in all of the cases that we will have to talk about in this course, that controller is an electronic circuit. So kung electronic circuit 'yan, it takes in voltage. Okay, it takes in voltage. Yung input niyan ng controller niyo basically is a voltage. And therefore, yung output niyan is also a voltage. Kasi nga electronic circuit siya. Okay? So kung electronic circuit siya, ang input niyan voltage, ang output niyan dito voltage din. Okay? So ayun. Which means your input transducer would actually convert your command to a voltage proportional to that command. Okay. For example, kung position yung input signal ninyo, that is you are setting the position of your say for example, elevator. Okay? You are setting the position of the elevator. The input transducer would actually convert that position to a voltage proportional to what the position reads. Okay? Kung 4th floor yan, meron yung certain voltage, okay, that is read by your controller. Okay? Maliwanag yan? Okay. So yun basically yung ginagawa ng input transducer niyo. Okay? It converts your input, okay, papunta sa voltage proportional. Okay? Dun sa command niyo. Okay? Now, what happens now is that the controller would produce an output voltage that can control the process or the plant. Okay. Now, your process of plant actually comes with a controller. Okay. Usually, kapag meron kang processor plant, lagi talaga merong controller yan. For example, kung ito ay motor, okay, meron kang tinatawag na motor controller. Okay. Kung yan ay compressor, as in the case of aircon or air conditioning system, meron kang compressor controller. Meron kang circuit to control the compressor. Okay. Yes, Mr. Bacamante, may question ba? Bigla rin taas ng kamay si Mr. Sige. So, ayun. So, basta tatandaan nyo na itong processor plant is the main component of your system that produces the output variable or the control variable. Whatever variable you are controlling, that output variable is produced by the process or by the plant. Okay? For example, if this is a position control system, kung position control system ito, that means your output is position. Tulad ng sinabi ko kanina. For a position control system, the position is the output. Okay? Now, the component that would produce this position may come out of a motor. Kasi motor yung magpapagalaw dun sa sa system mo, whatever system that is, whether it's say for example it's an autonomous vehicle. So yung vehicle mo would actually be moving because of a motor. Okay? And therefore, okay. So therefore, yung yung ating control variable natin na position is actually produced by the motor. Okay? So therefore, if you know what variable is being controlled or is being produced by your entire system, okay? You would also know what kind of component that would produce that output. For example, kung temperature control system naman, ang output natin is temperature. And what component produces temperature? Okay? It may be a compressor kasi baka air conditioning system ito. Okay? O kaya pwede ring hot wire. Hot wire means ito yung kapag in-apply mo ng voltage, iinit siya. As in the case, for example, ng plancha o ng ironing ng iron. Okay? So, yun yung mga ilan sa mga pwedeng processes or plant or components that could actually produce a certain controlled variable. Okay? Is that understood? Okay. So, now, we move now to the point wherein we can now consider those other things. Okay, those other things that can actually alter or change your output or affect your output. Okay, we call this disturbances. Okay, and then there are two types of disturbances. As you can see here, the diagram actually differentiated between two types of disturbances. Okay. But before I discuss those two types, okay, tandaan nyo lang that the diagram actually used a summing junction. Okay? And summing junction yield the algebraic sum, okay, of the inputs using associated signs. Which means you can use summing junctions in order to add two signals. Okay? So kapag meron kang summing junction, something like this, okay, it means that meron kang signal A at saka signal B. Okay, yung output niyan is signal A plus signal B. Okay? And in that case, ito tatandaan nyo. You can only add A and B if they are of the same quantity. Okay? So you can only add signal A at saka signal B if both signal A and signal B pertain to the same quantity. And therefore, the sum is also that same quantity. Kumbaga, hindi naman kayo makakapag-add ng apples at saka oranges. Okay? And produce whatever this is. Okay? So, hindi ganun yung natin. Ang alam natin, you can only add quantities that are of the same dimensions. Okay? So, in this case, since voltage ito, okay, since this signal is voltage, if we actually add this, okay, if we actually add this to produce this signal, okay, as the signal that controls your processor or plant, we remember that this disturbance should be of voltage nature. Dapat voltage din yung nature nung signal na yan. Okay, para ma-add natin siya sa voltage na to and therefore producing voltage that would control your processor plant. So dapat itong tatlong to pare-parehong voltages yan. Okay. And in that case, if this disturbance 1 is in the form of a voltage, then it could only come from a circuit. Okay? Actually, it comes from this circuit itself. Yung circuit mismo ng controller ninyo. Okay? Yung voltage na yan, it actually comes from this electronic circuit that is the controller itself. Okay? Ito yung mga spurious signals or unwanted signals. Like for example, white noise na napoproduce ng electronic circuit. So, take note that your electronic circuits produces white noise. Okay? That can actually add up dun sa ating dun sa signal na pinoproduce ng controller ninyo. And can actually disrupt or can actually add up and therefore change the value of the signal that would control the process of the plant. Okay? We call this kind of disturbances, itong disturbance 1, as internal. We call them internal disturbances. Okay, we call them internal disturbances. Okay? Is that clear? Okay. Now, and how about this? Okay, itong disturbance 2. Okay. So we know that this processor plant would produce the control variable. So therefore, kaya nga magpo-produce ng control variable dito. For example, kung position yan, this is also a position signal. Okay? Now, this disturbance too would actually be a signal that can actually alter the position. So this is also should be a position signal. Okay? And if we take a look, for example, meron tayong say meron tayong antenna, okay? Meron tayong parabolic dish na naka-deploy, for example. Yung parabolic dish na yan, as in the case for example ng ginagamit sa mga satellites. Okay, sa mga satellite to control the satellites. Kung maalala nyo kanina, meron akong Earth station dito. Okay, so ito yung mga Earth station na yan are actually used to control satellites. So ito siya sa ground. Okay. Now, ang kailangan sa mga antenna na katulad nito, okay, that is used to control satellites is dapat nakatutok yan. Kung ito yung satellite, okay, ito yung position ng satellite nyo in a far away place, okay, dapat nakatutok yan. They actually maintain a certain alignment. Okay, so that is why this antenna is oriented, okay, horizontally in terms of its horizontal axis, okay, and in terms of its vertical orientation. Okay? So, pwede mo yung kontrolin, or pwede nyo yung i-orient in terms of this angle or in terms of the angle with respect to this axis. Okay? Ito, yung orientation niya in terms of this axis, okay, is what you call the azimuth. Okay? While this one, okay, is what you call the elevation. Okay? So you orient your antenna in terms of these two characteristics or in terms of these two orientation. And both of them are actually expressed as angles. Okay, pareho yan naka-express in terms of angles. Okay, so that is why these two are actually yung orientation nila are actually angular displacement. Okay. Mararanasan niyo yan if you have parang mga yung mga halimbawa signal TV, yung parang yung sumasagop kayo ng cable signal or cable TV using a satellite dish. Okay, kapag yan kinabit sa bahay ninyo, if those are being installed in your house, one task of the installer is to actually orient the satellite or the dish, okay, in one way, in two ways. Yun nga, yung azimuth nga niya tsaka yung elevation, so that it could receive the maximum amount of signal galing dun sa source niya, which is the satellite. Okay? So, the thing is that if these are antennas for Earth station, malaki yan. As in malaki yan. It may involve yung parabolic dish nyo may involve a diameter of 2 meters or more. Okay? Malaki yung 2 meters na diameter na yan. Okay? And in that case, kapag yan nahanginan, if the wind blows, okay, this azimuth and elevation may actually be affected. Okay? So, itong wind na to, okay? So, the motor itself, the motor can actually be used to control, okay, yung azimuth, for example, or elevation, yung angular position nila. Okay, it can be used to control those things, those parameters. Okay, but the wind, okay, can actually add up to that angular displacement. Okay, so therefore, we can consider this wind as the disturbance too, which in general is what we call the external disturbances. Okay, we call this disturbance too as your external disturbances. Okay, and both disturbances are the undesired signals. Okay, that enters your system, whether internally or externally. Okay, so naintindihan ba to? Okay. So, ganito ang mangyayari dyan, no? Kung may open loop system tayo, at tingnan natin itong case na to. For example, the azimuth is set at 45 degrees. Okay. From north. Parang ganito ang mangyayari dyan. Kung titignan nyo yung antenna sa taas, yung top view ng antenna, ito yung azimuth niya. Yan yung azimuth plane niya. So, ito yung north, for example. I-orient natin yung antenna natin ng 45 degrees galing dun sa north. So, dito dapat nakaharap yung antenna nyo. Siya dapat nakaharap. This is looking at the antenna at the top. Because that's the azimuth, that's the azimuth plane. So, ito yung 45 degrees na sinasabi. Okay. So, if we now set your antenna to face 45 degrees or be oriented at 45 degrees. Okay. At your at the ibang color ng pen ang gamitin natin para mas makita niyo siya. This one. Okay. So, if we say that 45 degrees yung kanyang orientation. Okay. What would happen here is that the input transducer would convert this 45 degrees into a voltage proportional to the 45 degrees orientation. Okay, so from here, magiging voltage na siya, in which the controller would now convert it into voltage that can control the motor. So that the motor would then produce or would then turn, okay, would then cause the antenna to turn so that it would orient itself by 45 degrees. Okay, so simple, simple, straightforward system. Okay, now, but here's the thing. If there is a disturbance, halimbawa bumuga yung hangin, causing the antenna to change its position by 2 degrees. Okay? By 2 degrees. What would happen is that magpo-produce ngayon ito, okay, ng 45 degrees plus 2 degrees. Magiging 45 plus 2 degrees na to, magiging 47 na siya. So misoriented na siya ngayon. Okay, that is what would happen here. Okay, what would happen is that kapag sinet natin yung ating input into a certain value, okay, and then there is a disturbance that would actually alter that value, then we cannot do anything about this. Kasi nga, this is an open loop system. Okay, maliwanag yan? Walang mangyayari dyan. Okay. Now, pag naman meron tayong closed loop system, okay. Again, ang kinaiba nga nito is that it has an output transducer or sensor. And what this transducer do, okay, is that it actually measures the output response. It measures the output response, feeding the measurement back through a feedback path and comparing the response to the input at the summing junction. Okay? So, if there is difference or if there's any difference between the two responses, the input and the output, kapag may differences yung dalawang yan, the system drives the plant, okay, via the actuating signal to make a correction. So, what would happen is that once na ma-detect ng system ninyo via this, okay, via this signal, that there is a difference between the input and the output, may difference between this and this. Okay? As long as there is a difference between those two, this controller would continually drive the plant. Okay? In order for the corrections to be made. Okay? So, halimbawa, dun sa case ng i-discuss ko kanina, kung 45 yung input ninyo, okay? Tapos, halimbawa, wala pa tayong disturbance, no? In the absence of disturbance, eventually, magiging 45 degrees din yan. Okay? And in fact, ito mangyayari dyan. Halimbawa, sa una, 0 ito. Oriented siya as 0. So, as you can see, merong 45 degrees tsaka 0 degrees na difference yan. So, malaki yung difference yan. So, therefore, it would produce a very big actuating signal. Okay? It would produce a very large actuating signal. Okay? In which case, that large actuating signal, para mas matotohanan, no? Ito yung actuating, kasi yung difference naman nila is just basically a constant eh. Okay, so una constant siya. Okay. So madedetect niya na malaki yung difference na yun. Okay. So therefore, the controller would also produce a very large controlling signal. Okay. Thereby, driving your process or your plant to move faster. So since this is a motor, okay, it would cause this large driving signal would cause the motor to move faster. Therefore, ito, bibilis din siya or gagalaw din siya ng mas mabilis. So say for example, mapupunta siya sa 40 degrees. Okay? Now, your sensor would actually measure that the output now is at 40 degrees. So 45 minus 40 would produce a smaller signal compared dun sa nauna. Okay? So yung difference na yon bababa. So therefore, yung controlling signal nyo, bababa din. Okay? Which would then make the motor move slower than before. Okay? Mas medyo babagal siya ngayon sa paggalaw kasi mas mababa na yung controlling signal niya. Until such time, dumating na siya sa 45 degrees. Okay? So what would happen is that mare-reduce ito sa 0. Yung controlling signal niyo mare-reduce sa 0. So yung error or actuating signal niyo magiging 0. Eventually, yung controlling signal niyo magiging 0 din. At that point, your motor will now stop moving. Kasi nga, na-reach na yung 45 degrees. And your system would know it because there is 0 actuating signal or 0 error. Mamaya, didiscuss ko yung pagkakaiba ng dalawang yan. Nung error at actuating signal. Okay? Now, what would happen if there is now a disturbance? Okay. Say for example, your disturbance would introduce an error of 2 degrees. Okay, magpo-produce siya ng error na 2 degrees. Or ng difference between the 45 degrees tsaka ito. Okay, na 2 degrees. Okay. So meaning, halimbawa lang magiging additive siya. So mag-a-add siya dito sa 45 degrees. Magiging 47 yung output nyo. Okay, and in that case, since 47 siya, okay, malalaman niya ngayon that this sensor would then detect that there's a difference between the output and the input. Okay, which would then produce a signal. Okay, pero in this case, in opposite direction. Kasi mas malaki na ngayon to kaysa dito. Kanina kasi mas maliit siya. Yung output nyo, mas maliit dun sa input. Okay, this time, mas malaki yung output dun sa, or your output is larger than the input. Okay, so therefore, it will produce an error signal that is on the opposite end. Okay? So, your error activating signal is then this one. Becomes this. Okay? So, ayan, magkakaroon ngayon ng difference. Okay? Now, what would happen is that your controller would then produce a signal. Okay? Which would then again drive the motor. Okay? But the objective of that, okay, is to drive the error to 0. Okay, so meaning, ang gagawin ng motor nyo ngayon, instead of turning to increase the angle, it would actually work on to decrease. So it would actually move in an opposite direction as what happened here. So kung siya ay clockwise, for example, dun sa case na kulay blue, in the case of when there's a difference of 2 degrees, counterclockwise naman yung gagawin niya. So therefore, pabawas ito. From 47, bababa yan towards 45. Okay. So mangyayari yung cycle na yan until such time that this error signal becomes 0. And therefore, the controlling signal also becomes 0. Okay. And then, your motor again stops at, okay, mag-stop ulit siya at 45 degrees. Even there is a presence of a signal continuously. Okay, even there is a presence of your signal continuously that changes or try to change the azimuth orientation by 2 degrees. Okay, and that is one of the main advantage of your closed loop system. It can actually provide greater accuracy because pag sinabi mong 45 yung input, if your controller and your everything is well designed, you can actually reach that exactong 45 degrees. Okay, using a closed loop system. Kumpara dito. Okay, kumpara sa open loop system in which there is a chance that if the input is 45, the output might not be 45 degrees. Close to, but not possible na maging 45 degrees siya. Okay? So sa closed loop system, it is possible that you can achieve greater accuracy. Okay? Your closed loop system are also less sensitive to noise, to disturbances such as in this one, okay, and changes in the environment. Okay? You can also control your transient response and your steady state error. Okay? Now, when we try to control now, or when we try to design now your system in terms of this performance characteristics, take note ang pinag-usapan natin kanina is that the performance characteristics that we will take a look into are those of the transient response and the steady state error. Okay? Now, these performances can actually be modified. Mamomodify natin siya by, number one, changing your process or your plan. Ibig sabihin, yung component nyo, papalitan nyo mismo. Or number two, change your controller. Pero between the two methods, mas practical na palitan na lang natin yung controller kaysa yung plan. Kasi baka mamaya mamahaling equipment to eh. For example, this is a very large motor. Okay, so if this is a very large motor, okay, baka hindi rin siya basta-basta mapalitan. So it may be more practical to redesign your controller in order for you to meet transient response and steady state error characteristics. Okay? And that process of redesigning the controller is what we call compensation. Okay? And the hardware that results out of that compensation is what we call a compensator. Okay? Are those terms clear? Okay, may questions ba tayo so far? 2 paragraphs na nagtanong pa ako ng questions. Okay, so it says here that the main disadvantage of using a closed loop system is the complexity and the cost it entails. But sa totoo lang, we don't really look into the complexity and the cost if the benefits actually outweigh whatever complexity or cost disadvantages your system might have. Which means that if we can actually obtain a system that is really resistant to disturbances, okay, ano nga ba naman yung cost? Ano nga ba naman yung complexity? Okay? We really don't look into the cost and complexity if we can design a system that is resistant, especially if you require that your system be resistant to noise or be resistant to disturbances. Okay? So, although we always see, depende naman din sa system, but we always look into the trade-off between having a simple and cheap system, okay, and an accurate and expensive system, okay. Madalas kung ang kailangan talaga natin is a system that is really resistant to disturbance and really accurate in terms of its output, then that trade-off is actually not really that much of a big deal. Okay? So therefore, this disadvantage only plays into the design if yung differences talaga between the cost between the difference of the cost between a system that is disturbance resistant and a system that is not disturbance resistant is really big. Okay, pero kung maliit lang naman, hindi naman ganun kalaki or tolerable naman siya in terms of what we are trying to design, then we don't really have to think about these trade-offs. Okay, and one more thing is that the use of computers, okay, for compensation or for controllers. Okay, as we know, digital computers or computers are very flexible. Okay, so in terms of functions, okay, kasi yung computer nyo can actually do supervision, meaning it can monitor systems and it can monitor multiple systems. Okay, and in terms of control, okay, are actually very is actually something that is characteristic of a digital computer used as a controller. Okay, so most of the system today actually uses computer in order for not necessarily computer na nakikita natin as computer. Okay, they may come in the form ng, for example, Raspberry Pi, okay, or something like any specially designed computers for a specific purpose, especially for the purpose of actually of controlling certain systems. Okay, and isa pa, using computers as compensators or controller also allows you to use different techniques of control. Okay, not just yung classical control techniques natin, such as, for example, proportional integral derivative control. Okay, but rather you can use different non-conventional types of control. Okay, halimbawa nga neural networks, for example. Okay, or genetic algorithm. Okay, something like those. Okay, so ayun. Now it's 8:44 already. So meron pa tayong dalawang topics na i-discuss, but in this case, I'll just pass you up, or I'll just upload recorded lecture that would discuss this. Okay, that would discuss these things. Okay, so that you can study. Okay, you can as you read, there is also a discussion or recorded discussion that you can follow through para mas maintindihan niyo siya. Okay, so ayun, this would be our last meeting for this year, for the year 2020, because the next meeting that we will have will be scheduled sa sa 2021. Okay, earliest pero hindi ko sinasabing ito na yung schedule natin, pero the earliest that we can have a synchronous session for this course is January 5, 2021. But I'm not saying na final na yun. Okay, possible na baka January 8 na tayo unang mag-meet, pero let's see pa rin. Okay, pero in the coming weeks, in the next 2 weeks, I'll be uploading materials covering yung week 1, week 2 at saka week 3 topics. Okay, including a homework for each week. Okay, so para pagdating natin ng January, which is our week 4 based sa calendar natin, we will be able to continue now with the discussion. Okay, now I'm not saying that you spend your entire vacation in studying. Okay, I'm just saying na iiwanan ko lang siya, and then if you have time to go through the materials, please do so. Okay, may time ba naman kayo after ng vacation? Okay, o kaya mag-set kayo ng time, for example, after ng January 1, sa January 2 and 3 and January 2, 3 and 4, pwedeng i-set nyo yun as a time for you to study. Okay, so pwedeng doon naman after na. Okay, and next week kasi parang I was able to read dun sa ating announcement by the admin that we would have next week as asynchronous meetings, which hindi naman yung originally na plano ko. That is, I would set next week as asynchronous meetings. That is why nga tinatry ko tapusin ito. And that is why we had 2 synchronous meetings this week. Okay, so ayun. Now, please check this one. Pero halimbawa, tingnan natin yung notebook ni Mr. Abenoha. May nilagay na ako dyan na homework 1. Okay, so this is now your homework 1. Okay, in which you would have to answer this. Okay, dun sa row na to. Okay, when you write this when you write your answers, you write it here. Okay, so name 3 applications of feedback control systems. The 3. One example of application of feedback control systems is yan. Okay, so that's 1. Okay, so you can actually type in your answer directly, or sabi ko nga, it's either you type in or you write it on a piece of paper and then you scan it and then you upload it here. Okay? So, nandiyan na yung material ninyo. Nandiyan na yung assignment ninyo. So, you would be able to see na your homework would actually populate here. Magpo-populate yan dito. Okay? So, dito yan may ipon. Okay. Although, you also need to take note that you need to turn in your homework sa assignment tab. Okay? So, you might be seeing your homework this way. Baka mag-iba tayo ng view pero somewhere here, merong parang dyan, merong parang turn in button dyan. Okay? After you are done here, pag natapos nyo na to, okay, pagtapos na kayo dito sa pag-i-edit nito at nasagutan nyo na siya, please don't forget to turn in your homework here. Merong turn in button dyan, di ko lang alam kung saan siya napupunta kapag sa student interface. Kasi this is the teacher interface So I don't know kung saan napupunta yung student interface. Ay, saan napupunta yung turn in button sa Pero it's located here sa assignment button tapos dun sa homework 1 ninyo. Okay? And this is something that I would like to tell you or to tell you about how we implement yung soft and hard due dates. Okay? So may makikita kayong dalawang date dyan. Itong due January 12, 2021. Okay? Tsaka yung closest January 30, 2021. Itong January 12, 2021 is what we call the soft due date. Okay? Which means you can submit your work on or before this date. Okay? You can turn in your work on or before this date. Okay? But after this date, after January 12, you have until January 30 to turn in your work. So parang yun yung second chance ninyo to turn in your work. Okay? So ito yung soft due date. This would be the soft due date. And this would be the hard due date. Okay? Naintindihan ba yun? Okay. So, may questions ba? Regarding sa natin? Regarding sa content, regarding sa course, regarding sa homework. May questions? Sige, go.
Wala naman na po, sir.
Ay, wala.
Sa akin po.
Okay, wala na. Okay,
pa.
sige. Okay, so yung iba, wala na bang questions? Okay, so kung wala na, I think we can end the meeting here. Okay? So we'll see each other on 2021 na sa January. I-set na lang natin kung kailan tayo exactly what date or what day will we do a synchronous session. Okay, pero next week sigurado 'yun, asynchronous session tayo for Tuesday. Okay? Synchronous learning tayo for Tuesday. Okay? So, good night, everyone. Thank you for attending today's class. And ingat kayo sa bakasyon ninyo. Okay? Happy holidays. Okay? So, sige. Kindly leave the meeting na lang.